A very warm welcome to today's webinar on topic Building a Connected Quality Ecosystem. I'm Santoshi and I'll be the host for today's webinar. So before we begin, few housekeeping updates. All participants' microphones are muted and cameras turn off to maintain proper bandwidth. If you have any questions or clarifications, you can post them in the chat box. We'll also have a dedicated Q&A session at the end where we'll address your questions. Thank you for your understanding. Now let's get started. In today's competitive manufacturing environment, quality can no longer function as an isolated department. However, many companies still struggle with disconnected systems, scattered data, manual process, and limited visibility in quality performance. This is where the concept of connected quality ecosystem become essential. A connected quality ecosystem brings people, process, and quality data into a single collaborative framework. It always ensures that everyone, that is from operators and engineers to quality managers and leadership teams, is working with the same information and aligned towards the same quality objective. When quality is connected, communication becomes seamless, process becomes centralized, visibility improves across department, decisions become data driven, and performance improves continuously. Today, we'll explore how organization can build this ecosystem by connecting four pillars, that is people, process, visibility, and performance. Since 1993, Aegis India has been delivering engineering excellence and digital transformation solution to industries across India. With decades of expertise in engineering, service, digital quality system, and manufacturing transformation, Aegis has consistently helped business improve performance through innovation and practical solution. Built on this strong foundation, LiveQC Tools was developed by a team of experts with decades of experience to strengthen and simplify quality management system. With this background, today's session will provide practical insights into building a connected quality ecosystem and demonstrate how organization can leverage LiveQC tools to connect people, process, visibility, and performance for sustained business success. It now gives me a pleasure to introduce our speaker, Mr. Sanjeev, application engineer, who brings extensive experience in quality management system, manufacturing process, and digital quality transformation. He will walk us through practical concepts, real-world application, and how LiveQC tools can help organization build a smarter and more connected quality future. Over to you, sir.
Good afternoon, everyone. I would like to welcome you all for the webinar. Really glad to see so many of you joining today. Whether you are turning in the shop floor or from the management office, thank you for taking your time out of your Wednesday afternoon for this. I know afternoon can be get busy, so I'll make sure every minute here is worth your time. Before we officially begin, imagine this is a Monday morning. You walk into your plant and the MRN meeting is going to start. The meeting goes on and on and on and on and on. The quality team is quite relaxed because they have the weekly report. What does the weekly report holds? It has all the defect that is occurred last week and what are the NC kappa currently going on. But the twist is the head asks for the quarterly report. Yes, the team has the report. But the problem is they were unable to compile and trace it over. So they were making the calls, they were checking over the emails, and then switching over the spreadsheet. After the clock ends, they simply answered, "We will share it after the meeting." That moment, that pass, it is not the quality team's problem, it is the quality system's problem. Do you feel your quality system is disconnected? Then this is the webinar for you. Hello everyone, this is Sanjeev taking care of the technical part of the LiveQC software representing Aegis India Private Limited. So what is our topic today? Building a content quality ecosystem. So today we are going to discuss about how to build a content quality ecosystem. What is the word building? A quality ecosystem is not created overnight. It develops step by step through people, process, data, and evaluation of the performance. Just like a strong manufacturing process is built through a planning and control, a strong quality ecosystem is also built through connection and collaboration. Is everything connected? No. Every document will be in different forms. Control plan will be in PDF format, and then FMEA will be in Word format. And then the NC kappa will be in mail, and then control charts will be in spreadsheet. Whereas the audit document will be in paperwork. What if to build everything in an interconnected and single unified platform? That is what our Live QC tool is. Today, I'm going to walk you through about what we are going to see today. Who actually drives the quality? And an industry-based scenario. With that, we are going to pick a product and then a process. So that we are going to take a problem for that, so that what are the root cause they have conducted, and then what is the solution for it. So that in the end, we have a quite little summary and then the Q&A. To begin with, who actually drives the quality? Is who actually drives the quality? Is the quality manager or the auditor or the customers? Actually, quality starts with the operator standing near the machine. Every inspection results, every process parameter, every decision creates quality. Live QC simply gives visibility and connectivity to all these people. Let's see what are all the teams under quality. To begin with, incoming quality control. IQC is the team who is at the gate, who validate the supplier, then their performance, materials, and their documentation. Final quality control is the team who is at the end and validate the product before it reaches the customer. And then customer quality is the team, they will be in between the internal quality and then the customer. And then here's the most crucial team in process quality control team. It is the team that were responsible for the entire process where the 80% of the defects are born. So today we are going to pick a team from one of it, so that we are going to pick incoming process quality control. Today we are going to see who they are, what they do, and then how critical they are. To begin with, IPQC is the responsible for monitoring and controlling the product quality during manufacturing. They will be in the position to assure the quality where the quality of the product where to the final quality control. They will be bridge the gap between incoming quality control and then the final quality control. What they do, they will check the machine parameter, temperature, pressure, and then the process settings at each stages and then each steps. And they will also verify what are all the control plans, work instructions, it is up to date, and order who are all following it. Coming to the quality assurance, how they will assure? They will identify and segregate the non-conformance product at each stages. If something goes wrong, they are going to raise the NCR and trigger the corrective actions. How critical they are. A defect that is caught during the process, it's 10 times lesser than the cost or that caught in the final inspection, and then 100 times lesser than it caught on the customer end. What they actually do, they will detect the abnormality early, prevent the scrap, rework, and then the customer complaint. So we understood why IPQC is critical. Now let's see a real product where the IPQC play a major role. The product is automotive grab handle. Almost every vehicle has one. It may look like a simple component, but it contains multiple parts and then multiple manufacturing process. Let's understand this. Grab handle is not a part. It is an assembly. It contains plastic handles, hinges, spring, as well as the fasteners. Each component using each different process. Because of that, quality risk can occur at multiple stages. Let's see how these parts are manufactured. Handles and hinges are manufactured in an injection molding process, as well as the spring using spring coiling, and then the fasteners having a cold forming as well as in the thread rolling process. To begin with, injection molding process. How the grab handles are getting made. To begin with, a material ABS plastic material. Other materials also used as a nylon or something. What is next? Next, the material drying. How they will dry? Using a hopper dryer, they are going to remove the moisture content which cause critical defects like short, burn marks, and then other critical defects and all. And then here is where the heart of the process, injection molding. Here is where the material get melt inside the barrel and then injected to a mold and then get solidified, and then during a degating process, they are going to remove it. And after that, the trimming, sorting, inspection will happen. How IPQC team will inspection? IPQC engineers or operators open the live QC hosted check sheet on his laptop. The check sheet for this part, this machine, this shift is already loaded. The sampling plan is built in. He knows exactly which parameter to measure and how many samples to take. He measured the grab handle component, length, width, thickness, and then mounting dimensions. He enters each value directly into the digital check sheet. No paperwork, no late shift data entries. Real-time data entry on the shop floor. Shop floor entries are automatically updated within the platform check sheet, and this will be interlinked with the control chat for the real-time data monitoring. SPC is a crucial chat that validates the entire process whether it is capable or not. So that is all the parameters like control limits, CPK, PPK values get automatically calculated. This is how I have mentioned that how we are going to connect the process digitally. As you can see, as the operators going to like collect the data in a tab, and then it evolves over in our live QC software, and then it interlinked with SPC. This is how it connects the process. As you can see, a thickness is a critical parameter from the check sheet as it linked with the SPC so that it shows a real-time deformation. As you can see, there's a steep, the thickness is quite decreasing. So all these parameters get automatically calculated. The CPK value shows 1.17, but actually the CPK value should be 1.33. This shows there is a problem in the process. Let's see how they are conducting the root cause and everything. To begin with, they need to plan. Here comes the live planning. Quality manager need to assign a task to the particular engineer in a defined timeline and then their priority. So that if he defines it, automatically a Gantt chart get created. Every task is documented, assigned, time-stamped, and then tracked. Management sees work in progress across each person. Engineers have the clarity on their priorities. Nothing gets lost. Also, they can have a trigger notification and then they used to do whom doing what. What is the task? Also, they can have a reminder that's sent by the manager. Quality engineer were started why the thickness is varying. A quality engineer reaches the injection molding machine. He talks to operator. When did the thickness start varying? Has anything changed? Material batches, mold settings, or is anything has changed? After they collecting all the data, they came across a cross-functional team across all the department in a discussion room. And then they will come up with a solution. Let's what has happened and how they conducted the root cause and what is the actual cause through a fishbone. As you can see the fishbone, effect will be in the fish head and there is a 6M order all the possible causes. In our live QC software, you can able to develop your almost all the fish bones with the predefined templates. And then what are all the possible causes? The catch may drift, the ambient temperature get drift, the material may be the problem, temperature related drifts may have happened, or is there a cooling time reduced by the operator? The key feature here is you can able to attach each evidences for the particular cause to rule out whether to find whether the actual cause is. As you can see, the calibration drift, they have attached the MSA so that they can able to tell the gauge is still acceptable. This is not the actual cause. So that this cause particularly get ruled out. This is not the actual cause. And then if you are getting into material related problems as the IQC forms as get attached within the wishbone. As you can able to see, the moisture content, melt flow index, all are within the specs and it is getting accepted. And then we are going into an cooling time reduced by the operator. The production team has submitted a scatter chart. Let's see how the scatter chart works. All these charts are interlinked with the check sheets so that they can able to see there is no correlation between the arrow and then the line. As you can see, the cooling time is not decreased, but the thickness is getting decreased. So this is also not the actual cause. And then if you are seeing a thermocouple calibration drift, as a Pareto has attached to it. If you go and seize the Pareto, you can able to find out what are all the temperature related abnormalities that is logged for the last month. So that they have went to the particular machine, so check with the thermocouple calibration dates. In the check sheet, already the calibration dates are overdue. So that the calibration has not done at almost 6 days before. What actually happened? As the thermocouple is not calibrated, it shows 15 degree less than the actual temperature inside the barrel. So that the operator increases the temperature to excess 15 degrees Celsius. This implies the reduction in the thickness of the bar handle, so that all the actual causes get highlighted in the red, and what are all the ruled out causes is highlighted in the green. If I want to get the previous version, you can able to get in a single click as a previous version. This is how the version control works with the LiveQC software. The root cause is confirmed. Now the quality engineer need to formally document the problem and then assign the action. He writes the live NC and non-conformance report in LiveQC tools. He fills the problem description and then the containment section with the supporting evidences. As you can see, the description, whatever I have mentioned, is filled over there. As a containment action, they need to replace the thermocouple, and then all the less thickness grab handles need to get segregated. These NCs or all the files can send within a LiveQC software in a particular time period. We can give the privileges of read only or read write only, as you can send a notification with the messages too. So that the maintenance team investigated and they have come up with the corrective and preventive actions. The thermocouple functioning incorrectly is correct. The root causes is confirmed and the wrong temperature setting was being applied because of the outdated check sheet. So, as they have come up with a corrective action, that the thermocouple has been replaced. Here, live kappa directly linked with the NC, so no separate tracking containment actions, preventive actions are captured in one workflow. Status is visible to all the stakeholders in real time. What is the preventive action then? It is quite interesting. Where the real problem is, the paper check sheet won't remind when the calibration date arises. So that they have installed live calibration. Live calibration is a separate module in LiveQC tools. There you can fill the form with what are all the asset name with their specifications and then with the upcoming maintenance date. If the maintenance date arises, you can automatically get a trigger notification within the software as well as through mail. So that if the date arises even before 2 days or after 2 days with your privileged time, you can able to set it over there as an alert. As you can see, the asset management has given us a preventive action, and then the segregation starts. They are all the less thickness related grab handles get segregated. They are tagged, moved to the hold area and remeasured against specification. Part that passes re-inspections are cleared for assembly. Part that are out of specification are dispositioned, either reworked or scrapped. The assembly team knows which components are clear. The quality records are assigned within LiveQC tools. Now let's get to the next process. The cleared component move to the assembly. The handle, hinges, spring, fastness, all to come together, the grab handle assembly is completed. Now before it goes to the customer, it need to pass one functional check, a pull test. A pull test is a destructive function test. A specific tensile load is applied to the assembled handle. The test checks whether the handle hold under the kind of force a passenger would actually apply. In automotive, this test is non-negotiable. Let us see what happens. A pull test failed. Not one sample, multiple samples from same batches. The handle is not holding under the load. What is the root cause for it? The poor threading. Actual failure point is the fastener connection between the grab handle. So right away, a customer complaint has sent from the plastic industry to the fastener industry. Before we get into what happens in the fastener industry, we need to understand what is the fastener, how it is get worn. To begin with, as a raw material, we are going to take a steel wire. Here comes the IQC, checks with all the related specifications. And then with the wire drawing methods, we are going to reduce the size of the diameter of the wire with our required size. And in heat treatment process, it should increases the ductility formability so that we can able to easily form a head in a cold heating process. Using a circular die or a flat dies, we are going to make the threads in a fastener. And then the coating, whether it is a zinc coating or a black oxide based on our preferences. And then the coating is mainly for the corrosion resistance. What actually happened in this process? Why it is getting such a poor threading in the fasteners? The rolling dice in the thread rolling process get worn out condition. The investigation at the fastener supplier reveals it that thread rolling dies were worn out when a die wear it no longer presses the thread from a correct depth and the thread produces a shallower than specification. The fastener looked fine visually, but under the tensile load of a pull test, that shallow thread strips, the fastener pulls out and then the handle fails. So they have replaced the dies and then the process gets started again and then the fasteners are getting manufactured again. But the quality manager has a one question in his mind. Okay, one of dies is the reason for the poor threading, but how it passes our inspection? Is our gauge trustable? That's where the MSA study comes. MSA study is nothing but a measurement system analysis that's going to answer a single fundamental question. Can we trust our measurement system? Think about it this way. We can use a gauge to decide whether it is a good part or a bad part. But what if the gauge itself has variation? What if Inspector A versus Inspector B using a same gauge get the different result on a same part? What if the same inspector, same part, they are getting different result on Monday versus Friday? If your measurement system has high variation, your quality decisions are unreliable. You may accepting the bad part, you may rejecting the good part, and you will not which one is which. The MSA study qualifies that risk. There are types of studies in MSA: bias, linearity, stability, attribute, and gauge aranda. In gauge aranda itself, it has ANOVA total variation, tolerance, and then average and ranges. All these studies can be conducted in our LiveQC software. So here, an attribute study has been taken for a go no-go gauge for the fastness. An attribute studies is used mainly for the measurement design, that whether it is a judgmental, pass or fail, accept or reject, rather than the numbers. So go no-go gauge is the perfect example for it. We select 8 parts for the study, and as a critical step, the borderline parts are whether the measurement system is most likely to fail. The study designs is entered into the LiveQC tools. 3 appraisers were selected and 8 parts were coded. And how it works with the LiveQC software? Let's see. As you can see, the type of studies get selected and then what are the assets we are going to load over here. If the asset is not calibrated, there will be a warning symbol going to show over here. And you're going to select the in charge, all the appraisers, operator 1, operator 2, and then the operator 3. They are the person who is going to measure, and they are the appraisers who is going to conduct the study, whether they are reliable or not. Operator 1 gets the login, and he is going to measure each and every gadgets with the 8 parts, and you're going to enter whether it is OK or NG with a 1 or 0. So as after it is filled, it gets saved. So that each operator gets the login, they'll come into there, and then they are going to have each privileges. In a single click, you can get all the reports over here, whether the CAPA score, effectiveness calculation, and then the summary. Not only this, you can take and save it as a report so that you can able to share it with as an evidence or something to the suppliers as well as the customers. As you can see the PDF report, so that from the data entries to the results, it will be located over here. The CAPA score below is not acceptable. What does this mean? The go no-go gauge is being used to inspect these fastness cannot give the reliable results. The inspector were doing their job correctly. The gauge was failing them. This is why the MSA matters. Without this study, the team would have been changed the dies and continued using the same unreliable gauges, and borderline defects would keep slipping through. The root cause of the measurement failure would have been remained invisible. So what's next? The gauge get replaced. The old condition gauges, like inspected, that they have find out in an MSA study it is not reliable, so that they have removed the old gauges to identify it is a old gauge, and then they have installed the calibrated new gauges in service, so that they will verify and record all the related fastness that is in the segregation. How the segregation part goes. The root cause confirmed that the measurement systems are corrected. the system goes back to all the affected fastener batches. They are re-inspected using the new capable gauges. The MSA, the gauges, the replacement, the re-inspection, the corrective actions documented in live QC tools. A complete traceability, a complete accountability, and then from the problem to the closure. After 2 months, a quality manager has in their mind, is the process reliable after the corrective actions? So that he has one question, he's going to conduct an internal audit for the particular process validations. Here comes the live audit management to conduct the audit digitally so that so there is no paperwork for entirely get neglected. Let's see how it works with live QC tools. As you have a predefined template, you can get whether it is an ISO audit, third-party audits, or it is within our organization internal audit, or whether it is an like a custom audit, you can able to have a customizable template, and you can insert your auditor name, lead auditor, and you can able to expect a time frame from the start date to the finish date. You can give the audit title as an internal audit, as you can mention, and then the auditee and their auditee team. All these uses are predefined, so that why we are giving it here, so that each persons get each responsibility in each processes. As you fills the audit scope, and if you have any audit plan, you can able to attach, and then where it is happens. After getting saved, it automatically gives the template, and then as I mentioned, each process get each responsible, accountable, consulted, and then informed persons. So that these are the person responsible for attaching the evidences. As you can see, each process get each person as responsible. Let's take a person login and then gets into the audit now. As you can see, the person is attaching the control plan for the particular process. Here we have a separate control plan and FMEA module with a role linking feature, so that you can able to verify both are updated or not. As well as you can able to attach the external files to as an evidences. So auditor will right away come, checks the evidences, and then have the conformance and non-conformance. Here is the auditor login. He goes on to the auditor page. He verifies the control plan. Is the updated control plan is used all over there, and then checks with the operator, and he gives whether it is conformance and whether it is non-conformance. He's giving, and then he's going to have a FMEA, so that all the calculations, RPM calculations, are automatically get calculated, whether it is conformance or whether it is a non-conformance. Let's see whether they have a separate trigger system for the die for the one-out condition. As similar to the injection molding industry, they have it over here. And then they have submitted the updated MSA study for the new gauges, so that it is reliable now. So after he giving each and every, whether it is conformance or non-conformance, they are going to get us a report. Live audit plans are created and managed inside the live QC software. Check sheets are customizable, notifications are automatic, and audit is fully structured before the auditor walks in. Also, the audit reports, professional formatted audit reports, are auto-generated from the findings entered during the audit and stored permanently in live QC tools for the future references. So the team get all conformance, the process is stable now. What if a non-conformance given by the auditor? Audit findings automatically generate the NC within the live QC tools. The CAPA owner is notified instantly, and then the clock started to closure. As a summary, we will get the score, what are all the inputs they are predefined in the backend, so that each process will get the score and get it as an audit summary. Let's get back to where we started. Remember last time, team was scrambled with the files, reports were unable to trace it, and then compiling it. Imagine the same scenario. Imagine the same scenario over here. Imagine the same scenario over here, so that the quality manager walks into the meeting. So if the same question arises, so he can able to open the dashboard right away. He can able to show it what are all the things that is currently going on, whether the defects are repeating for the last 3 months or whether what are all the NC kappa are currently in the open condition. So this dashboard get developed with interlinked with a check sheet as well as all the forms inside. Also, we have a RCA dashboard, whether he need to like explain what has happened, how he conducted the RCA, what are the solution he has gotten, so that he got the dashboard, so that he can able to explain over and over in the meeting itself. As a summary, let us bring full story together. We started on a Monday morning where the quality team could not answer question in real time. A process deviation on an injection molding line, SPC caught the drift, root cause analysis was found the problem, NC Kappa closed it with a live calibration. Fastener failure, then the measurement system failure, and hiding behind it, a MSS study found the catch that this was letting bad part through. Replaced, revalidated, supplier collective actions were raised, fixed, and validated. The auditor arrived, no scrambles, no running, every records in the systems, every kappa with the closure status. The audit summary generated in minutes. And finally, the quality manager opened the live QC tools, able to show the dashboard within 30 seconds. That is what the digitalization looks like, and not replacing your quality team, just empowering them. Is the quality tools only have our live QC tools have only this much of features? No. Other features also we have. Let's like as I mentioned, control plan FMEA, whether the person will get updated after the root cause get conducted, the person will update the control plan and they won't update the FMEA. So that these kind of things and all will neglected with a row linking feature, so that you can able to verify whether the both process are updated both in the control plan and FMEA. We have our control plan and FMEA and the root cause get conducted in 80 forms too. And then we have a separate module as PPAP to start from the design records and end with the PSW. All the 18 documents get accumulated over here based on the level privileges you can able to submit it to the customer. So if you are looking for any other demos related works, you can able to have this QR over here, so that you can right away scan this, so that you can register for a one-on-one demo to understand what are the struggles that you are facing, so that we can able to understand how to implement the live QC tools in your way.